So in this video, we're going to be looking at solving trig equations, so solving for an angle theta. But when we do that, we'll notice that actually it's more complicated than you might originally think. So normally if you're solving an equation like this, sine theta equals 0.3, then how you'd solve it, if you remember from grade 10, is you would do the inverse sine, right, of the 0.3, and that gives you a number for the angle, and the number I get there, inverse sine of 0.3, in my calculator is 17.46 degrees. And that's true, but that's actually only one answer here. So we could just call this theta 1. That's only one solution. There's actually more than one solution here. If I draw this on my unit circle will kind of show me why there's more than one solution. Sine of theta, if you remember, sine of theta is y, right? So y is sine of your angle on a unit circle. So if I'm told that sine of theta equals 0.3, that means the y value will be 0.3. So I'm looking for points where the y value is 0.3, and that would exist there and there. And so the first angle that you can see here is this one, that y value right there, and that is indeed theta 1, the 17.46 that we just found. But there's actually another angle too, right? Because this also shares a y value of 0.3. So there's also a theta 2 going on here. We need to calculate that one as well. So to figure out what theta 2 is, you can notice that this is kind of a symmetric thing. So to get theta 2, what you're going to do is start from the positive x-axis like we always do, go over to 180 degrees, and then back up by that distance right in there, which is also theta 1. So to calculate theta 2, what you're doing is go all the way to 180 degrees and then subtract theta 1. So this works for any kind of equation that's like sine theta equals something. You'll go all the way to 180 degrees and back up by your initial angle. This initial one is the one that will always pop out of your calculator. So theta 1 is just what you get from your calculator. Your calculator won't tell you theta 2, but it is actually still an answer, so it's still an important one. So you want to do 180 minus the 17.46 there, and that gives you 162.54 degrees. And so that's my other answer. So there's actually two answers here between 0 and 360 degrees, 17.46 degrees and 162.54 degrees are the two answers. You can check your work just by plugging those back in. So check that sine of 17.46 equals 0.3, and it does. And check that sine of 162.54 equals 0.3, and it does. So if you do sine of those, you should get back the 0.3 again. All right, let's do a negative one. So if you're told that sine of theta equals negative 0.5, so we remember that sine is the y-axis. So this means the y-axis is at negative 0.5 here. So the 2 points that would have a y value of negative 0.5 are here and here. So those are the angles I'm looking for. And I'm looking for them from the positive x-axis, rotated around like that, and from the positive x-axis rotated around like that, right? I want them as positive angles because I'm looking for the angles between 0 and 360. But watch what happens when you plug it into your calculator. So when you do theta 1, that's just the initial angle that comes out of your calculator. You do that by doing inverse sine of the negative 0.5. This is how we would do it in our calculator. This is actually a special angle, so you could use your special angles as well for this. But just to show you how it works with your calculator, we do inverse sine of negative 0.5, and that gives you negative 30 degrees. So that's an answer. Negative 30 degrees is a solution to this equation. Like if you do sine of negative 30, you will get negative 1/2. But it's not in the range we're looking for. We're looking for between 0 and 360 degrees. What's happening here is that your calculator is trying to get to that one of those terminal arms as quickly as possible, and the quickest one it can get to is by going backwards by 30 degrees instead of going forwards. So to get theta 2, you can actually still do it the same way though. So theta 2 is still going to be 180 minus theta 1. You just have to watch out for the signs now because theta 1 is negative. So you're going to do minus a negative 30 here, which is going to give me 180 minus my negative 30 is actually positive 210 degrees. Theta 2 is 210 degrees. That's this angle right here, the angle over to there. So that's theta 2. Now, how am I going to get theta 3, the green one here that I've drawn? Because that's also clearly in between 0 and 360, and that's the one that I want. I don't want this backwards negative one. I want to get to the same terminal arm. I want to get here, but I want to write down basically a coterminal angle with that going positively. So if you remember how we get coterminal angles, we get them just by adding or subtracting multiples of 360. So what you want to do to get theta 3 is take your theta 1, which is negative, and just add 360 to it to make it a positive number. So instead of going backwards by negative 30, we could go forwards by positive 330 in this case. So that would be your negative 30, that's your theta 1, plus 360 gives me positive 330 degrees, and that's theta 3. So there's sort of 3 answers here, but there's only 2 that are in between 0 and 360 degrees, and that's your 210 degrees and your 330 degrees. It's always a good idea to check. So make sure you check that sine of 210 is indeed negative 1/2, and it is, and check that sine of 330 is indeed negative 0.5 or negative 1/2, and it is as well. All right, so just to summarize that, if you have an equation that's just like sine of theta equals k, so sine of your angle equals k, and you're trying to solve for theta, then you're going to get thetas in different ways. The first way, using your calculator anyway, is just to do the inverse sine of k, and that's what you knew from grade 10 trig. But once you found the first angle, that's actually not the only answer. There's more. We have to get the second angle, and that would be 180 minus your first angle. So this is the rule for sine theta equals some number k only. So this doesn't work for cos theta equals some number k or tan theta, right? This is only going to be true for sine. And then our last one, if you end up that theta 1 is negative, so you can't do a negative angle, that won't be between 0 and 360, and then you need to find a coterminal angle. So this is just finding a coterminal angle here. Coterminal angle. And you only have to do that if theta 1 is negative. So only use if theta 1 is negative. Otherwise, if theta 1 is positive, then adding 360 to it is going to take you out of the range of 0 to 360, right? So that's not going to be necessary. So why is that the case? This picture kind of summarizes it for us. So if k is here on our unit circle, some y value, right, because sine theta represents the y value, then theta 1 is that first angle you automatically get, but theta 2 would be going all the way to 180 and then backing up by theta 1. So 180 minus theta 1. And theta 3 we would get if we had a negative 1, and we have to go around again to find a coterminal angle. This is just a little bit of foreshadowing to our next unit. We're going to be graphing sine function soon, and this is actually what the graph of the function sine theta looks like. You can notice that when sine theta, so that's going to be the y value here, is equal to some number, it hits in 2 places, right? It hits at theta 1 and at theta 2. And we'll look a lot more closely at that graph in our next unit. All right, let's do cos. So cosine, if you remember, is x. So x is equal to cos theta on your unit circle. So if I know that cos theta is 0.3, then on my unit circle I should look for the x value 0.3 and find 2 points on the unit circle that have that x value. Well, those would be here and down here. So those are my 2 angles, measuring them from the positive x-axis there. Theta 1 is going to be that first angle from the positive x-axis over to that first point that shares that x value of 0.3. And how we get theta 1 is the same way you've done it in grade 10. You do the inverse cos of 0.3, and that gives me inverse cos of 0.3, 72.54 degrees. Okay, but how am I going to get theta 2 here. So theta 2 is all the way around to here, right? I'm looking for that angle there. Well, you can see that what's going on here is that you're going actually all the way to 360 degrees and then backing up by theta 1. So the method to get theta 2 for a cos function is going to be this. We'll do 360, go all the way over to 360, and then subtract our theta 1. So numbers wise for us, that's 360 minus 72.54. And 360 minus 72.54 is 287.46 degrees. And so that's my other angle. So those are my two solutions between 0 and 360. And you can always check them. So I've got theta 1 here. And I've got theta 2 here. So check on the side. Cos of 72.54 is indeed 0.3 or very close to 0.3 within rounding. And cos of 287.46 is indeed 0.3 or very close to that within rounding. Now when cos is negative, it's actually not as messy as when sine is negative. We'll see what happens here. So if I look at negative 0.5 for cos is on the x-axis, so I'm looking at that point right there. So I'll be looking for this angle and this angle. Now here I've called the angle x, that is still just an angle, right? So you're still looking for like essentially a theta. So the first one that you get out would be from the positive x-axis over to here. So it's going to be the first one. Because I've written an x in here, I'll call that x1. It's the same thing as theta 1. So x1 is going to be the inverse cos of the negative 0.5. So you'll toss that into your calculator. This is also a special angle, so you could also use your special angles for this. But we'll just use our calculators for now, just to sort of see how that works. And we get x1 is equal to 120 degrees. To get x2, it's actually the same strategy as before. So x2 is going to be all the way around to here. That's the other angle, right to here. But to get there, we're going to be going all the way over to 360 and then back up by x1. So that means that x2 is going to be 360 minus x1, or for us, that would be 360 minus 120. And that gives me 240 degrees. So x2 is 240 degrees. So those are my two answers there. x1 is 120, x2 is 240. You can check on the side. Cos of 120 is indeed negative 0.5, and cos of 240 is also negative 0.5. So that all checks out. All right, so to summarize that with cos, if you use your unit circle, remember cos theta is something on the x-axis. So if cos theta equals k, then I'm looking for a k value on the x-axis. I draw my 2 points that have that x value of k, whatever number k is. I can draw my 2 angles to them, and I draw them from the positive x-axis over. The first one just is what pops out of your calculator when you do the inverse cos of k. The second one is going to be 360, so all the way around to 360, and then back up by the theta 1, so minus the theta 1. If you ever do need a theta 3, you can always find a coterminal angle this way, but that's not usually necessary because even if k is negative, both theta 1 and theta 2 will pop out positive there. So you don't usually need to do that. Just a little bit of foreshadowing of where we're going here. This is what the cosine function looks like. So you can see when cos is equal to some k value, that happens at 2 different thetas. And you'll notice that the difference from 0 to theta 1 is the same as the distance from theta 2 to 360. And that's why that 360 minus theta 1 move works. But we'll spend more time with those graphs in our next unit. All right, our last one is the tangent. So for the tangent, the graph of the tangent is a really cool one. This is what it looks like here. It has this repeating pattern every 180 degrees. And so what that means is that the theta 1 that you'll spit out of your calculator is just, you do inverse tan of k gives you theta 1. But then to get to the next one, the next angle after that, you actually just have to add 180 degrees to the first one. And to get a coterminal angle, so this is just finding coterminals, terminal angles. That would just be add 360. This is useful if theta 1 is negative, which will happen sometimes with tan theta. So let's say we have tan theta equals 1.5. We want all the solutions between 0 and 360. Well, to get your first angle, you're going to do the inverse tan of the 1.5. So inverse tan of 1.5 gives me 56.31 degrees. And to get theta, sorry, that's theta 1. Theta 1. And to get theta 2, all you have to do is take theta 1 and add 180 degrees to it. So we'll take our 56.31 and add 180 to that. And that gives me 236.31 degrees. So 3 there, sorry. So that's theta 2. We don't need to add another 360 to our theta 1 because I don't need a coterminal angle here. Theta 1 is already in the range I want between 0 and 360 degrees, and theta 2 is as well. So I don't need to go any further than that. I found my two answers. Let's just check and make sure they're good. So you'll do tan of 56.31 degrees, and that should give you 1.5. That checks out. And then do tan of your other angle, 236.31 degrees. And that should also give you 1.5. Make sure that checks out too. And it does. All right, one last example. What if tan is negative? So what if you have something like this? Tan of theta equals negative 0.8. Well, then you get your theta 1 the same way as usual. Theta 1 is the inverse tan of the negative 0.8. And when I plug that in, do inverse tan of negative 0.8, I'm going to get a negative number, and I get negative 38.66 degrees. All right, to get the next angle, theta 2, what we do is we just add 180 to that. So theta 2 is going to be theta 1 plus 180. So we take the negative 38, do watch the sign, and add 180 to it. And that gives me positive 141.34 degrees. And then finally for theta 3, I need to find a coterminal angle with theta 1, right? Because theta 1 was negative, just need to find a way to get to that angle positively, which would be to take theta 1 and add 360 to it, find that coterminal angle. So take the negative 38.66 and add 360 to it, which is, so negative 38.66 plus 360 should give you 321.34 degrees. And that is theta 3 there. So my two answers that we would go with here are the ones between 0 and 360. So that's theta 2 and theta 3. You can do a quick check on the side. So check that tan of 141.34 is indeed negative 0.8, and it is. And check that tan of 321.34 is indeed negative 0.8, and it is. So this all checks out.